All right, so today we get into solving power equations. And again, just like solving a quadratic or a cubic, when we solve a square root. So it's again very similar, just another way to look at it. This time we have something on the other side of the equal sign. So we want to take care of getting anything extra outside the radical over to the other side. So the first thing we are going to do is get rid of the 4 by adding it. And when we do that, I get 9 equals 3 times radical x minus 5. Now I can divide by 3, so I can isolate the radical totally by itself, and I get 3 equals the square root of radical x minus 5. So just like we did radical equations, all right, I got to square both sides. When I do that, excuse me, I get 9 equals x minus 5, and I'm going to add 5 to both sides, and I'm going to get x equals 14. Again, that's all we're doing is solving for x. Okay? And the other one, similar to it, now, if you look, I have a binomial squared, so I want to get that by itself. So I'm going to add 4 to both sides. All right, I'm left with 12 equals 3 times x minus 5 squared. So I'm going to divide by 3. I'm going to isolate the binomial squared just like I did the radical. And I get 4 equals x minus 5 squared. So here, I'm going to take the root of both sides. So the square root of 4 is 2, and then I got x minus 5. And then if I'm going to rewrite that up here, because I kind of out of room over there. When I add 5 to both sides, I get x equals 7. Okay? So it says, if you compare the graphic representations of solving these equations, and if we just label them, well, here's the graphic representations, right? This is g of x equals 5, because that's 5 going across the line. Here is the function that we just solved, f of x. And our intersection point, which x was 14, well, if you notice, that is the x-coordinate of the intersection point. Okay? And then you got the parabola. Okay, so this here is j of x, because that equals 8. And of course, this is the parabola, h of x. All right, and we had 7 as a possible answer. Okay, which is this. And if you notice, it does intersect here, but that's not one of the solutions, so that's got to be extraneous. Okay? And that's what we're going to talk about down below here. It says, why does one of the equations have one solution and the other have two? Well, again, a square root equation will only have one point of intersection on the graph. So these square roots will only have one point. And of course, the quadratics have two because of the parabola shape. Okay. You know what? I actually, when I took the square root of this, I made one little mistake. This should be plus or minus 2, right? So not only did I find this for plus 2, but then I got to do minus 2. Sorry about that, ladies and gentlemen. When I add 5 to both sides, I get x equals 3. And there's our second point. Okay? Not bad. All right. Now let's talk about cubic. So we go to solve these. Again, get rid of everything outside the cubic root. So add 3 to both sides. And now, to get rid of a cubic root, I got to cube both sides. Well, 4 cubed is 64. I'm left with 2x minus 7. That's a horrible 7, by the way. Here we go. Um, and now, if I add 7 to both sides, I get 2x equals 71, and dividing by 2, what is 4? Every time I write, it just moves things all over the place for me. And I get x equals 35.5 as a solution. And if I go over here to the other one, now I have a cubed. Again, I want to add 7 to both sides. So if I have a binomial cubed, I want to take the cubic root of both sides. So the cubic root of 8 is 2. Can't be negative 2 because that has to be the cubic root of negative 8. And I got 2x minus 4. So if I add 4 to both sides, I get 6 equals 2x divided by 2. X equals 3. Okay. And if we compare those representations, well, we know this graph right here is g of x. The red line is your f of x. And you can see the point of intersection. It even tells you it's at 35.5, 1. Okay. And the other one, you can see the cube function. So the cubic root is kind of the s is sideways, where the cube is kind of vertical. You see the point of intersection right there at 3, 1, and 3 was our solution there. So the x part is 3. And again, this here, the blue line is j of x, and the red line is h of x. And why do both equations only have one solution? Because they only have one point of intersection. So let's do a couple problems down below, just check it for understanding. Alright, so if I have a cubed function here, and again, it says indicate if there's any extraneous solutions or no solution as well. So when I subtract 4 to both sides, I am going to get this, and I'm going to cube root both sides. So I get x minus 2 equals, this is going to be negative 4, because the cubic root of negative 64 is negative 4. And then if I add 2 to both sides, I get x equals 2. Okay. Again, I can plug this in here and check it. And that's x equals negative 2. So if I plug it in and check it, well, I get negative 4 cubed. And the cubic root of the negative 4 cubed is negative 64, plus 4 equals negative 60, so it checks. And we know that's our answer. Okay? Anytime you're solving something, you can always check it. Alright, so now I got a squared, right, function here, so if I subtract 4 to both sides, alright, I get x minus 2 squared equals negative 64. And now we're going to take the square root of both sides. Problem though is when I take the square root of negative 64, right, it's no solution, right? We're not dealing with the complex numbers here. This is radical, so this is no solution. All right, and then on the bottom we got some square root functions. So down below, again, you need to square both sides to isolate the, get rid of the radical. So I got 3x minus 5 equals, this is x squared minus 10x plus 25. I'm going to try to get everything on the left side by subtracting 3x and adding 5. That's that's 0. And I'll have my quadratic over here. So this factors into x minus 10 and x minus 3. So again, we're going to set them both equal to 0. And x minus 10 equals 0. So if I go back to the original equation and plug them in, if I plug in 3, so I have basically 3 times 3 is 9, so 9 minus 5 square root equals 3 minus 5. And the square root of 9 minus 5 is 4. And the square root of 4 is 2. That does not work, so that's extraneous. And if I plug the 10 in, well, 3 times 10 is 30, minus 5 is 25, and 10 minus 5 is 5, and the square root of 25 is 5. That checks. So we have one solution, and then one extraneous. Alright. And then last but not least, we got another square root one, so we're going to square both sides. So I got x plus 2 equals x squared. And I'm just going to move these on over. So I'm going to have x minus 2 and x plus 1. And if I set them both equal to 0, x equals 2 and x equals negative 1. So let's check them. Okay. If I plug a 2 into here, the square root of 2 plus 2 is 4 equals 2. Okay. So I know the square root of 4 is 2, so 2 equals 2. That checks. So that is a solution. So let's see if we have 2 here. If I plug a negative 1 into here, so the square root of negative 1 plus 2 is 1, and x is negative 1. Well, 1 does not equal negative 1, so that is not a solution. That is extraneous. And that is the power equation. It's just simply, kind of an extension of what we did with the radical equation.